based on organic chemistry. So I just want us to revise through this particular important topic that do come in an exam. So these are the revisions. Like I told you that I'll be getting exam questions and try to explain them, make a lesson out of those questions. So in this lesson, I want you people to follow me clearly and attentively. You are given this particular structure that is here. Have you seen? First of all, you need to know the name of this particular structure. They may ask you, what is the name of this structure that is here? So the name of the structure, this one. So if you are told to give the name of the what? Name of the structure. What is the name of this particular structure? So the name of this structure, this is called a structure of what? Tellurine. This is the structure of tellurine. So the structure of tellurine looks like this. This is how it is. So I want you people to be writing down everything that I'm explaining. I'm trying by all means to make organic chemistry so simple. So what I'll be doing is that I'll be getting today, I get this topic, tomorrow I get that other topic. So like the way I've done organic chemistry, next lesson I may also do organic chemistry. That other day I do salts. So we've stopped doing those lessons like topical lessons, looking at the time that we are remaining with. But I'll be trying by all means, even as I'm teaching, I'm also trying to touch on those topics. And sometimes I'll be giving you these lessons so that you go through them, you understand them just like this. So we'll be balancing on two. By the end of the day, a distinction must come out. So the structure of this, the name is a what? This is a tellurine structure. So a tellurine structure looks like this. They may also ask you another name to another question to say that name the type of linkage that is in this polymer. This is a what? This is a polymer. The word polymer, when you look at this particular word polymer, when I tell you what is a polymer, the word polymer means a large what? A large molecule. So a word, this word polymer, meaning a large what? A large molecule. A polymer is a what? Is a large molecule. And how is a polymer formed? A polymer is formed when we combine small units which are called monomers. So when we bring small monomers together, we combine them, we get to form a large molecule. That large molecule is what we get to call a what? A polymer. So a polymer is a large molecule. And the process of joining these small monomers to form a large molecule, that is called polymer. That particular topic is what we get to call what? Polymerization. So it is called polymerization, the process of joining these small units of monomers to form a large molecule. That is called what? That is called polymerization. So I posed a question here. This can be question number 1. Then question number 2, they may ask you to say, name the what? Name the type of linkage. Name the what? Name the type of linkage. They may tell you to say, name the what? Name the type of linkage. Name the type of what? The type of linkage that is found in this particular structure of tellurine. So a tellurine gets to have these linkages that we get to call what? You may put an answer there as ester linkages, or you may put something like a polyester. All these qualify to be what? Answers. They are going to mark you. You can say it is a polyester. You can say it is an ester linkage that gets to be found there. So tellurine structures get to have these ester linkages. So I can say ester linkage, or I can say polyester. This is it. So if they tell you to say now, this structure that is given here, now enclose or put a circle on an ester linkage where we've got an ester linkage. Ester linkage, it is here. This is an ester linkage. Have you seen this one? This is what we get to call an ester linkage. So have you seen what I've done? If you were told to say, okay, circle an Easter linkage. This one that is here, this is an Easter linkage. It is a Easter what? Linkage. This one that is here. It is just like this. This is the linkage, Easter linkage. It is just like this. Have you seen? So just like this, you are able to understand this. I believe we are able to move together. You are able to follow me closer. Have you seen? I'm revising with you these exam questions. I don't just want you to know these or master them, but I want you to have that full picture, that understanding, so that if you are to meet these questions in an exam, you won't even face challenges, because I'm not only teaching you like answers is dialect, I'm explaining so that this information gets to enter your blood. You get to understand such questions if they are to come in an exam. You may also find another question. So this is just an exam question that I'm trying to explain here. So even as I'm teaching, you're also writing down, trying to analyze these particular questions. So you may also find another question to say, they may ask you to say that, what naturally, they may ask you to say, what naturally occurring substance, what naturally occurring what? Occurring a substance contain an Easter linkage. So what naturally occurring what? Occurring substance will contain what? Will contain this linkage. This what? This linkage. So the question is this linkage, then a question mark here. So you start analyzing, okay, so now they're talking about a what? A naturally occurring substance that gets to contain this type of a linkage. So what are those naturally occurring substances? So now we get to look at what we get to call what? Natural macromolecules. Those ones that get to occur naturally. They are not man-made like synthetic macromolecules, no, or artificial macromolecules. They are those ones that we get to call what? Those ones that we get to call natural macromolecules. These ones are natural what? Occurring macromolecules. So the one that gets to have this linkage, we know the linkage that we are talking about. This is an Easter linkage. So you're able to agree with me that those ones get to have what? Those ones are fats. This is the reason why I tell you that the structure of fats gets to be similar to those of what? Terrarin. So we can say fats, or we can put here what we get to call what? We can put vegetable oil. So I can say vegetable what? Vegetable oils. So these are what? These are naturally occurring substance that gets to contain this type of linkage. So you can put this or you can put that as an answer. It is just one and the same. I believe you are getting something and you are knowing how to answer these exam questions. This is an approach. This is how we get to approach questions that do come in an exam. So the same way I'm digging them, the same way I'm explaining them. Have you seen answers that I'm putting here? I'm not even complicating things, but I'm making your life easy so that if you are to find such questions in an exam, you will be able to answer them. So let us now go to another question. So let us say that maybe you are given another structure of neon. So let us go to neon, where you are given another structure. So they may tell you, you may find a structure that is like this. I've already said an answer. So a structure that is like this. Have you seen? You get to have this structure like this. So you've got something like this. I guess you are enjoying this. I want you people to be enjoying this, because once you enjoy a subject, it becomes even simple. So like this, we've got C, then double bond there. We've got something like this. So this is just like a short thing that I want you to know. That's just something like this. Okay, find something here. We've got C, double bond. We've got N there. Then we've got something that is like this, something that is looking like this. Have you seen the way this structure is? So this is the structure of what? This is the structure of a neon. So this is a what? This is a structure of a what? A neon. So that is a structure of a what? Structure of a neon. That is just a structure of a neon. So you may find another question to say, another synthetic polymer is neon. So this is also a synthetic what? Polymer. So neon and tellurine are synthetic what? Polymers. So they will tell you, draw the structure of a neon. This is a structure. So if they tell you to say, draw the structure of a neon, this is a particular structure of a what? Of a neon. So the structure of a neon is just like this. This is how you need to put it. Now, you may also find another question to tell. They may also tell you to say, draw now the what? Draw the structure. Draw the what? Draw the structure. Draw the structure of what? The structure of a complex. They may tell you to say, draw the structure of a what? Draw the structure of a complex what? Carbohydrate. Complex carbohydrate, they may tell you to say, draw the structure of a complex carbohydrate. So carbohydrates, complex, have you seen a box like that is like this? You just put this. So this is a carbohydrate. It is just going like this. As simple as that. You just shade these things. You just shade them. So you just do what? You just shade them like this. So this is a complex structure of a what? A carbohydrate. This is how it is. I believe you are able to get something. So what I want from you is to get an understanding. After this particular lesson, you go through these things, try to understand them. So we've started these intensive revisions so that even as we get to go, we begin to move, we begin to advance together. You start understanding this at a deeper level, especially those of you that were there when I was doing organic chemistry. You are getting to understand this. But even the way I'm explaining, even someone that is getting to know these things for the very first time, I guess you are able to understand. You know, okay, a structure like this is how it is supposed to be. Okay, something like this, it is supposed to be like this. Just like this, we are advancing together. So it is just like this, we are knowing these things, we are able to do what? We are able to understand them. So when I was starting, I talked about a polymerization, where I explained a structure of a polymer. I guess so. You are able to follow me there. So I told you to say that we've got two types of what? Two types of polymerization. This is what you need to understand. So I told you to say that a polymer is formed from a process called what? Polymerization. It is formed from this particular process. Polymerization is a process of joining small monomers to come up with a large molecule that we get to call a polymer. That is what polymerization is. Just a process of joining. So we've got two types of what? So I'm going to say we've got two types of what? Two types of polymerization. So I'm going to say two types of what? Two types of polymerization. You can write there two types of what? Polymerization. Namely, there is what we get to call what? There is what we get to call addition. So there is what is called as addition polymerization. So there is addition polymerization. There is also what is known as condensation polymerization. So there is condensation what? Condensation polymerization. So these are two things that you need to know. So you may find questions in an exam telling you to say, give a difference between addition polymer and a condensed polymer. So whenever we are talking about addition polymerization, so when we go to what? Addition polymerization, a key difference that you are able to note is that when we are undergoing addition polymerization, you discover that a polymer is the only product. So polymer is the what? Is the only product. Is the only what? Is the only product. So polymer is the only product. We just get to form one thing. So we are just going to form one thing. For example, so I'm also putting up examples here. When we get to my what? To my ethene. So to my monomers, ethene, we get to form a polyethene. We are just going to have one what? One polymer. So we just get to have one product. It is just what? Only the product that is formed. So polymer is the only product what? Product that is formed. But when we go to condensation polymerization, so when we go to condensation what? Condensation polymerization, you are going to agree with me that here we get to have what? We get to have a polymer is going to be formed. So a polymer plus what we get to call water. So water gets to be formed, gets to be a product, or we can say what? Small molecules. So small what? Small molecules also get to be formed. So these are some things that you are supposed to know whenever we are talking about this. So I'm just trying by all means to summarize this, and you try to get an understanding. Even as we get to advance, these are certain things that you need to know. So we are going to look at major things together so that you are able to answer even exam questions, just like this. So this thing, you discover that you get to know everything. By the time we are going to enter into that exam room, you are going to be very hot. So this is what you need to get. So this is it. So I've given you some differences between addition and condensation polymerization. These are the two types of what? Polymerization that you need to get and understand. You can also have a question in an exam. So let us now move to another question. So we proceed to the next question. So I will say next question. I've answered a lot of questions. I don't even know this question that is here. We can proceed now to the next question, where you get to have something like, they'll tell you to say that copper, they may tell you to say that copper what? Copper 2 oxide. They'll tell you to say that copper 2 oxide can oxidize. Can do what? Can oxidize. So it can do what? It can oxidize what? It can oxidize a butano. So it can oxidize butano to liquid. So it can oxidize butano to liquid. So what they are telling you here, before I even give you a question, if they are saying it can oxidize butano, so meaning it can make butano to undergo a process we get to call oxidation. So oxidation of butano gets to give us a carboxylic acid. In other words, when butano is oxidized, a product that is formed is called butanoic acid, which is a carboxylic acid. So this is what you need to know. I believe we are advancing together and you're able to understand all these things that I'm trying to explain here. I'm making them simple so that you are able to get like this. So you may have a diagram that is like this, and you need to know that whose pH is what? Whose pH is what? pH is 4. So the pH is what? pH is 4. So the carboxylic acid that is formed there, it gets to have a pH of what? 4. Acid, you know that acid gets to have pH values less than 7. So that is it. You get to have something like this. A diagram, you just find something that is like this. Simple things that gets to confuse us. You look at this, then you're even confused. We didn't do this with the sir. But these are things that I've been teaching. Gets to have something like this. So something that gets to be like this, then you get to have water there. You get to have water like water. Even there, you get to have certain things. So here, you get to have something that gets to be formed down there. So there, you can have a liquid like that. You get to have two things. So here, I may say, here there is, let me do this. Here, this is where we've got what? Copper 2 oxide. So copper 2 oxide is like this. Then this one that is here, this is where we've got amino wood. So here you've got what? You've got amino wood. So I may say amino what? Amino wood. So this is amino wood soaked in what? Soaked in butano. soaked in butanol, like this, butanol. Then this one that is here, so this one that is here gets to be liquid X. So this is what? This is liquid X that is formed. So this is liquid X that is formed by what? That is formed by oxidation of what? Butanol. Oxidation of what? Oxidation of butanol. You get to have this set up in an exam. Have you seen the way it is? Those of you that have been going through exam questions, you are going to agree with me that, sir, I've seen this a question somewhere. You get to have a question like this. The first question, they may ask you to say, give another reagent that can oxidize butanol. So they may ask you to give another what? Another oxidizing agent. So we are looking at what? Oxidizing what? Agents. Oxidizing agent. So give another what? Give another reagent that can oxidize butanol. So that can oxidize an alcohol, another reagent. So oxidizing agents here, one of which is this one. Have you seen? You've already known this one. And that other one that you already know, so you can put what? We can say this is what? This is potassium. So I may say what? Potassium manganate. So potassium what? Manganate. Manganate. So potassium manganate 7. So this is what? Another oxidizing agent. This is question A. I'll put this as question A. This is a what? An oxidizing agent that you need to get. So this is an oxidizing agent that can be used here. You can also be told another question to say, which homologous series do liquid X belong to? Have you seen? So they are telling you to say which what? Homologous series. So homologous series of what? They're telling us to find homologous series of what? Homologous series of liquid X. So homologous series of liquid X. The liquid X that is formed by oxidation of butanol. So when you oxidize butanol, when butanol undergoes oxidation, a product that is going to be formed there is going to be a carboxylic acid. To be specific, the name of that carboxylic acid, we are calling it what? Butanoic acid. So we are talking about carboxylic acid. So the homologous series, the family to which this acid belongs to, we get to call it what? Carboxylic acid. So the answer there, you just say what? Carboxylic acid. You just put that as your answer. You just say carboxylic acid. What I want you to get is an understanding. I don't want you to master these things. I want you to get that understanding. All you need is an understanding. Once you get to know these things, these are simple things that you are supposed to get. So this is what is happening. I guess we are moving together. You are able to understand this. So this is it. Then another question that you may find, they may now tell you to say, give the chemical formula of substance what? Substance X. So question C, they want you to give the what? The formula. What is the chemical formula now of X? Chemical formula of what? X. What is the formula of X now? So have you seen that this setup was just to confuse us? Because they know that there are people that get to be discouraged the moment they just see my diagrams, these experiments again. So they get to be discouraged. They know that there are such kind of people that get to be discouraged. You just see this thing, then you are discouraged. Oh my gosh, this thing. So you need to make sure that you interpret what you are given. If it is mathematics, I like graph work because we get to approximate answers. Answers are not the same. So even those of you that get to do experiments, you get to give according to your observation. You don't need to look at your neighbor. Maybe your neighbor is making a mistake. You are doing the correct thing. My neighbor, this liquid has turned this to this. just concentrate on what you are doing. So after this particular session, notes are everywhere, and I'll also I'll make sure that maybe tomorrow, that other day, I'll try to forward in some lessons that you need to get and understand. So just from these things that I'll teach, I'll see, by God's grace, I'll see what I can do if I may push in an exercise. But if there is no exercise given, don't worry about anything. It's a sign that you need to be studying. You just need to be studying. So make sure you are doing some studies. You just need to make sure that you are studying. Your duty is to study. The more you study, the more you understand these things. So you just need to make sure that you are doing what? You are doing some studies. Okay, so let us now look at the formula of X. What is this formula of X? This is now oxidation of what? Butano. So I'm going to lab this part so that you understand clearly what I'm teaching here. So we are talking about that liquid X is formed via oxidation of butano. So oxidation of what? Oxidation of butano. Oxidation of what? Oxidation of butano. So we are talking about butano. Butano is an alcohol. So alcohols get to have a chemical formula which is CN, then we've got 2 like this, then plus 1, then they get to have OH there. This is the chemical formula. N is standing in for the number of carbons. So we know that if it is 1, the name should start with what? The name starts with methanol. Have you seen? If it is 2, the name starts with ethanol. If it is 3, the name will start with propanol. If it is 4, the name will start with what? Butanol. If we are talking about alcohols, but if we go to a hydrocarbon, you discover that that is also another thing that will come in. Another thing, it will be, if it is alkane, this is going to be what? Methane, ethane, propane, butane, if it is an alkane. But since we are talking about alcohols, we are going to revise through everything. You are going to know everything. I always tell you, you need to be content with the information that you get to gather. You are supposed to be breaking nights, studying, making sure that you understand all these things that I'm teaching. You may not know this when you've got maybe 2 days before exams. It is good to revise through. You get to polish up. So, for example, this is butano. Butano is here. Number what? Number 4. So number 4. There meaning this is what? This is 4. So C are 4, then plus C. Have you seen? This is 4 times, have you seen here what is happening? 2 times 4, 8, plus 1, 9. I put 9 there, then I put OH. This is OH. The OH we are able to see here, this is the functional group of an alcohol, which is called an hydroxyl. So if they ask you what is the functional group of an alcohol, it is called an hydroxyl. It is called the what? An hydroxyl. That is an hydroxyl. I believe you are able to get this. That is an hydroxyl. So we are calling it what? An hydroxyl. An hydroxyl. That is a functional group. So a functional group of alcohols. A functional group. So we are saying a functional what? A functional group. The functional group, we get to call it an hydroxyl like this. An hydroxyl. Which is like this. This is an hydroxyl that we are talking about. All alcohols get to have my OH at the end. That is an hydroxyl. An hydroxyl. I guess we are moving together. So it is oxidation of butano. So I say plus oxidation, it is reacting with oxygen. What is going to be formed this side is a carboxylic acid. The name of the carboxylic acid is called what? Butanoic acid. So what I'm going to do is this. I say, okay, this is the C. Have you seen? So you need to know that 1 carbon gets to drop. So drop 1 carbon. Then have you seen, you drop one carbon like this to form a functional group. So one carbon is dropped, 2 hydrogens are dropped there. So what are we going to remain? C3 H what? 7, like that. This is what we are going to have. Then the C that was dropped comes here. Then from the 2 here, 2 oxygens get 1. Then write CO, OH. I put OH. So this thing that is here, this is butanoic. Then we get to have another product plus to my hydrogen 2 there. You can ask, sir, to my hydrogen 2 bidi tututwere kwisa ututubiri apapachala kamu na kabiko kapanga menshi. So meaning that we've formed this liquid X. This is the chemical formula. This is the chemical formula. What is the name of this? This is now what we get to call what? Butanoic acid. So this is what we are calling what? Butanoic acid. So this is the chemical formula. You write it just like that. Some people write it like this. See, they'll put 4, H there, they'll put 7, have you seen? Or they may put 8 there. 8, then they may put O2, like this. This is also, have you seen? Ama carbon yadianga 3 plus 1, 4. Ama hydrogen 7 plus 1, 8. Ama oxygen yadiabidi. So it can also be like this. Have you seen the way it is? C4H8O2. It is just one and the same. So you don't have to be confused. These are things that get to confuse people in an exam. So you don't have to be confused. You just answer them just like this. Have you seen the way this one is? So you just answer it like this. So this is the chemical formula. I don't want to give you a lot of things. No. So what I want from you, I want you to give me write an equation for the oxidation of what? Oxidation of propano. Oxidation of what? Oxidation of propano. This is like a simple exercise that I want to give you. You write an equation like this. Have you seen an equation like this? You just write it like this. Then you write something that is looking like this. You try to summarize it. So that is like a simple exercise.